Welcome. So in this presentation I'll be covering a topic on turbocharging in engines. Engines are basically power producing devices, and many researchers are working continuously on enhancing the output of the engine. They're using different strategies. One way of enhancing the output is using the supercharging method, and if we are using energy of the exhaust, then it is also called as a turbocharging. Based on air induction, we can classify engines in two types. One is naturally aspirated engine and second one is supercharged engine. In naturally aspirated engine, induction of air into the cylinder is because of the pressure difference between atmospheric pressure and the cylinder pressure. So there is a parameter which is called as volumetric efficiency, and this volumetric efficiency depends on how much amount of air is inducted based on the capacity of the engine. Generally, for naturally aspirated engine, the air which is inducted is always less than the capacity of the engine, because the exhaust gases which stays in the clearance, they're affecting the induction of the air into the engine. But if we use a method wherein we are forcing in air into the engine, then we can actually induct more air than the capacity of the engine, which we call as a supercharging. Now in supercharging, what we are doing is we are using a compressor which is either driven by engine itself, so the power of engine is utilized for driving the compressor, or the other way is the exhaust gas which is going out of the engine, it is also carrying some amount of energy which accounts more than 30%. So this energy can also be utilized for driving the compressor, and that we call as a turbocharger. So as far as supercharged engines are concerned, now since we are inducting more amount of air into the engine than its capacity, so we can always expect to have volumetric efficiency which is more than 100% if we calculate it on the basis of atmospheric pressure and temperature. So supercharged engines obviously will give us more output. How? That we will discuss in the coming slides. So if we consider the engine driven supercharger, then we can say that IC engines power is utilized for operating the compressor. So they are either you can use a belt drive or a gear drive to operate the compressor, and obviously when air is being compressed, the temperature will also rise, so there is a cooler in between engine and the compressor which will cool the air which is being compressed by compressor, and then it is inducted into the engine. Now here the pressure which is the pressure at which air is inducted into the engine is slightly higher. It is almost 50% more than atmospheric pressure. In naturally aspirated engine, as we saw, the pressure difference between atmospheric pressure and cylinder pressure is responsible for induction, and atmospheric pressure is approximately 1 bar. Using supercharger, we can increase it to about 50%, that is, the induction pressure will be about 1.5 bar. Now when you are inducting air which is at higher pressure, 50% more, we can expect that the oxygen which is available in the cylinder is 50% more, and proportionately if we inject more amount of fuel, then same size engine can generate more amount of power. So here this concept is also called as a downsizing. So this figure shows the supercharger which is engine driven. So as I told you, the engine power is utilized for operating the compressor, and compressor in turn will compress air to a pressure which is 50% more, which is inducted in the engine, and engine generates more power. Now here, since we are utilizing power from the engine, the output from the engine may not be very high. But if we have a turbocharger in which exhaust gases are utilized for operating a gas turbine, and this gas turbine in turn is coupled to a compressor which is actually compressing air, then here the energy which is being wasted, that is utilized for operating the compressor. So here actually we are utilizing the waste heat and we are generating more power. So here if you see the components of this turbocharger, then it consists of a turbine which is operated using exhaust gases, and this energy, as I told you, is more than 30% of the total energy which is available in the cylinder. Then it is operating a compressor. The input pressure is maybe about 1 bar, and then we are increasing it to about 1.5 bar. Now when we are increasing the pressure, obviously temperature also rises, so there is an intercooler here which will cool the temperature, which will cool the air and remove the heat, and then it is inducted in the engine. Now if you induct it without cooling, then obviously the volumetric efficiency may reduce because the density is less when the temperature is high, and if you are cooling it, the density will be high, so more mass will be inducted and you can inject more amount of fuel and generate more amount of power. So since we are utilizing waste heat to operate a compressor, this method is more efficient as compared to engine driven supercharger. So in most of the engines nowadays we are using turbochargers instead of superchargers. If you compare the thermodynamic cycles of naturally aspirated engines and turbocharged engines, then obviously we can expect more power from turbocharged engine because the amount of oxygen which is inducted is more. One more thing is, since we are utilizing exhaust gases which are thrown out at pressure which is greater than atmospheric pressures, so turbocharged engine, now if you see this thermodynamic cycle, this line, it indicates the exhaust gases, pressure at which exhaust gases are thrown out, and those exhaust gases are used for operating the turbine. Turbine in turn will operate the compressor, and compressor will supply air which is at higher pressure. Now here you will see that the pressure of air which is inducted is high, so obviously after compression the pressure at the end of the compression inside the cylinder will be high, and the overall mean effective pressure of the engine will be high, so obviously the power output will be high. Secondly, if you consider the naturally aspirated engine, exhaust gases again are thrown out at pressure which is higher than atmospheric, but the induction occurs at a pressure which is lower than atmospheric. So you have a loop which is generally a negative loop. So this loop, it consists of pumping work which is required for suction, exhaust. So this is considered to be negative in naturally aspirated engine. But if you consider a supercharged or turbocharged engine, then this curve, it is the positive loop. So it is actually contributing to the work output. So in turbocharged engine, both the loops, which comprises of suction, compression, power and exhaust, both the loops are positive, and therefore the output is more. And in naturally aspirated engine, one loop is positive but the other loop, which is pumping loop, is negative, so the output is reduced because of the pumping power. So this is the advantage of turbocharged engine. So So if you consider the advantages of turbocharging, then obviously since you are generating more power from small size engines, the power to weight ratio is high. Since the load on the engine, which comprises of the engine load, the passenger load, the vehicle load, is less because of small size engine, the fuel economy is also high. Another thing is, when you have higher pressure inside the cylinder, combustion is more proper, atomization is proper, so fuel economy in that case is also improved and combustion is better. Generally there is a problem with turbocharging which is also called as turbo lag. Now in turbo lag, what happens is, if you are suddenly accelerating the vehicle, and the quantity of air which should be inducted into the cylinder should be more, but when you accelerate, the exhaust gases which are going out of the engine, they are not sufficient to cater the requirement. Now what is done is, instead of using a normal turbocharger, a variable geometry turbocharger in which the aspect ratio of the turbine inlet nozzle can be changed. So this type of turbocharger can reduce the turbo lag. So there are various ways of turbocharging wherein you can combine the exhaust manifold of each and every cylinder and you can supply the exhaust gases to the turbocharger, or you can utilize a nozzle which will convert pressure energy into kinetic energy and then supply it to a turbine of the turbocharger. This is called as a pulse converter. So this kind of strategies can be used for improving the turbocharging efficiency and reducing the turbo lag. So that's all about the turbocharging. Thank you.